Okay everyone, so now we are learning the two-dimension array or called 2D array. Whenever we are having an array in which we are having rows and columns. So here in the example we can see that there we are having an array in which we are having this is the first row. Then afterward we are having is the second row. So these are the two rows. So here afterward I am representing that there are two rows. And we are having some columns. So we can see that there are 1, 2 and 3. So 3 columns are there. So we can say that this is 2 cross 3. Here 2 is representing number of rows and 3 is representing number of column. So such type of array is called 2D array. And there are further names of this array, such like we can say it is a matrix or it can be a table. So we can say that two-dimension array or the 2D array is an array which contain rows and column. That means here we are having rows and column, and their examples are matrix. Whenever you are using such terms, such type of example in the math, so that is called matrix. And let's say you are using a Excel file, then there we called it as a table. So table, matrix, they are the examples of 2D array. First of all, we are learning that how to declare the 2D array. That means the declaration of 2D array. Here, first of all, we are going to provide the type. Type means the data type of array. Just like integer, float, character. So which type of array we want. Then is the array name. After the array name, we are going to provide, first of all, the row size. Then bracket close, and afterward again bracket start. So here we provide column size. So we are taking the example here. Let us suppose that the type we are providing is the int. That means it can store the integer type of values. Now we are providing the name of array. So here let's assume that we are providing A. So the name of array is the A. It is a 2D array, so it is having 2 dimensions. So first of all, we are providing the first dimension, which is the row. We know that rows are 2. So here we are providing first dimension. That means row size, this is 2. Then afterwards, second dimension. Second dimension is the column. We know that columns are 3. So we are providing 3. So this is the declaration of 2D array. So whenever we are dealing with the 1D array, we know that simply we are going to provide the data type int, then the name of array A, then only one dimension, let's say 2 here. If we are dealing with the 2D array, then afterward we are going to provide, let's say int as a data type, name of array, then afterward first dimension which is row, and second dimension that is column. Similarly, if we are dealing with the 3D array, in the similar manner, we will provide the int, which is data type, name of array, first dimension, which is 2, second dimension, let's say 3, and the third dimension, let's say 2 again. So this is how we can provide the multi-dimension array. We know that 3D is the multi-dimension array. So on, we are going to provide the multiple dimension. So here we are learning the 2D array. So we are going to take the example of 2D array here. Now afterward, whenever we are declaring this 2D array, so inside the memory, we will be having reserved the blocks in the way just like rows and column. Here we know that we are having is the row and the row size is 2. That means array will start from index value 0 and go till 1. So the range of array is 0, 1. That's why we have provided the 2 rows here. Index is 0. And the next index is 1. So we can see that 0th row. So here this is the complete row, which is the 0th row. Then is the first row. So this one is the complete first row. So this is how we can represent the row. Second dimension in the 2D array is the column. We can see that here is 3. So that means 0 to 2. So here this is the index value. So we can see that 0, 1 and 2. So these are the index value for the column. So here we are having is the first column, which is the 0, then the second column, which is the index value 1, then is the third column. So these are the 3 column. If somebody asks you what is the size of array, so here we can see that rows are 2 and columns are 3. So that is 2 and 3. And 3 into 2 is 6. So the size of 2D array which we have declared is the multiplication of row and column, that is 6. That means 6 elements can come here. We can even check. So here I am assuming that the first element is 10, then the next element is 20, then 30, then afterward the next element is 40, then 50, then 60. So we can see that here 6 elements are coming. So that is the multiplication of row and column. We know that array is the sequential memory allocation. So how this memory is allocated into the system? So we can see that here the first block, which is 0, 0. So this is the first block. That block address, that will be 300. So this block address will be 300. We know that here we are dealing with the integer. Int consume 2 bytes. So that means next address will be 302. So 302 and afterward 304. Now the next address will be, that is 306, then 308, then afterward 310. So this is how the address will be given to these blocks. So whenever you are declaring at that time, the address will be provided. We can see that here we have given 6 items, that is called initialization of array. So now we are learning the initialization of 2D array. First of all, we are learning the compile time initialization. Means whenever I am making a program, at that time I am providing the value. Means before execution, program knows what are the different values. So that is called compile time initialization. Means I am writing the program and providing the value. So the first example I am taking here, let us suppose that I am saying int. So this is the int a, and in the bracket I am saying 2, then 3. So this is called declaration. Means we have declared the array into the memory. Then afterward we are going to provide the initialization. So afterward I am saying equal to, I am providing the bracket. We know that 2 into 3, that is 6, means 6 elements can be there. So I am providing the 6 elements here. So here 10, 20, 30, 40, 50, 60. So I am providing 6 elements here. So this is called the initialization. So by saying that, we are going to provide the elements. So here 10, 20, 30, 40, 50 and 60. These 6 elements will be allocated, means initialized to the array. There is one more way by which we can write this. So let us suppose that I am writing in the similar manner. I am saying int a, then 2 and 3. So this is the rows and column, means 2 dimension. This is called declaration, equal to, now here bracket start. In the bracket I am providing one more bracket here. So let us suppose that here I am saying 10, 20, 30. So here the bracket close. This is one row, comma, then again bracket start. I am saying, let's say 40, 50, 60. This representation is more readable. So if you talk about the first initialization representation, here we can see that compiler check that there are 2 rows, and in the 2 rows we are having each row with the 3 elements. So automatically compiler see that the first 3 elements belong to first row. So this is the row 1. Then the next 3 elements belong to the row 2. So here compiler automatically check. In the second representation, it is more readable. We can see that here, starting from curly bracket till the end, this is the row 1, or we can say that it is the first dimension. Then afterward, again, starting from curly bracket till the end, this is the row 2. This is again the second row. So here the representation is more clear. We can see that the row 1, which is 10, 20, 30. So here in the array, this is row 1, and row 2 is the 40, 50, 60. So here both the representation are same. There is one more way of writing this. You can simply write, let's say int, then afterward a, 2, 3. We know that 2 is the first dimension, 3 is the second dimension, means row and column. Then afterward equal to, now the curly bracket start, again curly bracket start. So you can see that here I am providing 10, 20, 30. So this is the first row. Then afterward comma, you can go to the next line. Then you can write here 40, 50, 60. So here it is again more readable that you are providing the first row and second row, then afterward bracket close, then you are providing the semicolon. So this is how we can also initialize the array, and we can see that the first bracket till the end, that is representing it is the first row, and afterward again starting with the bracket till the end, this is representing is the second row. There is one more way of initializing the 2D array in the similar manner. We can write simply, which is int, that is the type, then the name of array is A. Now the first dimension we are not providing here. Then we are providing the second dimension only, that is 3. And afterward we are saying equal to, in the bracket we are providing the all elements which we want to initialize. Let's say 10, 20, 30, 40, then 50 and 60. So all the elements we have initialized. Now here the first dimension need not to be provided. There is an important point to understand. When you are providing the complete initialization, means here you are representing that the first 3 elements is the row. So this is row 1 and the next 3 elements are the row 2. So you are pretty much sure that all the 6 elements you have given, means you have given the complete initialization. At that time, you has to only provide the column value. The row value is not required, or we can say that first dimension is not required whenever you are initializing the array completely. So here we should understand that whenever you are providing the complete initialization, means here the 6 values are there and you are providing all the 6 values, means 10, 20, 30, 40, 50 and 60. So here the column size, that means 3 is required, but the row size is not required, means you provide or not, that doesn't matter. So your initialization will be totally perfect. But let us suppose that you are writing the same line and you are saying A. So here you are providing the row, but you are not providing the column. Let's say column is you are not giving, and the rest of the line is same. Let's say you are saying int. So this is the declaration. Then afterward you are providing their values. Let's say you are initializing with 10, 20, 30, then 40, 50 and 60. So this is the initialization of the array. So this is wrong. This is not the way of initializing. So this is wrong. That means only rows you can cancel, means that size you cannot provide, that will be perfectly fine. But here the column size you are not giving, so that will be wrong because column size is required. So here rows compiler can manage, but column compiler cannot manage. So here the second one is the wrong initialization. So we have to go with the first, means you can skip the rows only. Let's say I am writing here int. Now afterward I am saying A, which is the name of array, then 2, which is the row, then 3, which is the column. Now afterward equal to, I am providing the initialization. Let's say I am saying again a bracket start, I am saying 10, 20, 2 values I am giving only. Then comma, let's say I am providing only one value, which is 40. Now you can see that 2, 3. So here this is the 2 cross 3 means 6. 6 elements should be there, but I have given only 3 elements here. So what is going to happen in that case? Here we know that the first part is the declaration. So here starting from int until that, this is the declaration part. And the declaration we are saying that int. So int means this is the data type. Then afterward the name of array is A. So we have provided the A as the array. Then there are 2 rows. So we have given 2 rows, 0 and 1. And there are 3 columns. So starting from 0, so 0, 1 and 2. So these are the 3 columns. So here the array or the matrix size is 2 cross 3, which is the rows and column, that is 6. So 6 elements are required. We know that afterward we are providing its value. So that is called the initialization of array. And in the initialization, we has to provide the 6 values. But what is going on here? We are saying that the starting from first bracket ending. So here this is the row 1. Now we are giving only 2 values, 10. So in the row 1, 10 will be stored. Then 20. So 20 will be stored. Now afterward we are putting the comma. Then starting bracket and the ending bracket. So that represents it is the row 2. And we are giving only one value, which is 40. So what is going to happen? compiler automatically provide all the remaining values as 0. So first row 0, then remaining values will be 0. So whenever you are not providing all the elements, means you are not initializing all the values at that time, they will be 0. We are taking one more example here. Let us suppose I am writing here int, this is the data type or the type, name of array is A, then row, which is the first dimension 2, then column 3, which is the second dimension, equal to, now here the brackets start. Inside that I am simply writing 0, then afterward comma, then again bracket start 0. So here bracket close. Now what is going to happen? So here in this example we are saying the type of array is int. This is an integer type of array which will take the integer values. Then the name of array is A. So we have given the array A. Then rows are 2. So here 0 and 1 are the rows. Then columns are 3. So here there are 3 columns, 0, 1 and 2. So this is the declaration, means the complete first part is the declaration of array. Then afterward we are having is the curly bracket start until the end. So this is called the initialization, means we are providing the values here. So here we know that the array is of 2 cross 3 and the size is 6, means 6 elements are required. But here I am only saying the bracket start and close, that is representing the row 1, and I am giving only 0. So here the first element of row 1 will be 0. Then again row 2. So here in the row 2 again I am saying 0. So again row 2 element is 0. So what is going to happen? Compiler will initialize all the remaining elements automatically to 0. So here 0, 0, 0 and 0. So we can see that here all the elements of array will be 0. So if you want that all the elements of array will be 0, no need to provide all 6 zeros. Simply write first row and second row value as 0. So all the elements will be 0. So this is how we can initialize the array. Now we are going to take one real life example of a program. With the help of that we will understand that how array work. So now we are learning this C program. Here we have given the first line as a comment that 2D integer array. Compiler will not read this because this is a comment. Then afterward we are having is a header file which is hash include. This is the preprocessive directive and it is including the header file stdio.h, which is for printf and scanf functions. Then we are having is the void main. Void means no return type. Main is a driving function. Inside that we are having the declaration part. So here the first part from int till a23, this is the declaration part. And here we are saying int. So declare an integer array A. So A array is declared. 2 is the number of rows. So rows are 0 and 1 index values. Then second dimension is the column which is 3. So here columns are 3. So 0, 1 and 2. These are the index values of column. Then afterward we are having is the initialization of array. So there complete initialization we are doing. This is the compile time initialization. Because when we are making the program, at that time we are giving its value. So this is the compile time initialization. We are not asking from the user. When the values are asked by the user, at that time it will be runtime. But right now it is the compile time. So here we know that the first 3 elements, they will represent the row 1. So there 10, 20, 30. So we are writing in the row 1, 10, 20 and 30. Then afterward, the next 3 elements will be representing the row 2. So here 40, 50, 60. So in the row 2 we are writing 40, 50 and 60. So here we have given the value. So this is called initializing the array. So we have declared and initialized the array. Now is the time to display the array. After that we have said I and j. So 2 more variables are declared into the memory. So here the first variable we have declared, which is I. Let's say the address is 701. Then there is one more variable which is declared. Let's say the address is 801. And here this is variable j. There is a simple concept of understanding. Whenever you are dealing with the 1D array, means 1 loop. Dealing with the 2D array, 2 loops. 3D array, 3 loops. And so on. So here we are dealing with a 2D array. That's why there will be 2 loops. So here one for loop for the rows and second for loop for the column. So here we can see that the first for loop which we are saying that is the outer loop. So that is representing the rows. Now we know that rows are 0 and 1. That means 2 rows are there. We know it. So here I will start from 0 and I will be going till 2. So if we start with the loop, we know that the value of I will be starting with 0. So here the value of I will be initialized to 0. Then condition check, I less than 2. So here 0 less than 2, that is perfectly fine. So afterward it will be coming inside. Inside we are having is the another for loop. So that for loop is for the column. And we know that columns are 3, that is 0, 1 and 2. So these 3 columns we are taking. So starting from j equal to 0 and the condition will be j less than 3. So here the value of j we are initializing, that is 0 right now. And the condition is set that j less than 3. So here 0 less than 3, perfectly fine. Now come inside. Afterward, we are having the loop. So here we are saying printf means printing on the screen %d for the integer value. It will take the integer value from aij. So that value will be coming here. And we know that I and j value is 0, 0. So a 0, 0. So now understand a 0 and 0. That means we are fetching the value which is 10. So that 10 value is fetched and displayed. So here we are having the output. In the first row, we are representing on the user screen that the value is 10. Now afterward, %t, that is giving a tab space. So we can see that there is a complete tab space between the second value. After that, it is a loop. It will go back and j++. So here the value of j will be incremented and the value of j will be 1. Again checking the condition, j less than 3. So 1 is less than 3. Perfectly fine. Again coming inside and again printf line will work, and here %d for the integer value, it will take the value from aij, and we know that aij value right now is 0 and 1. So here 0 and 1 value, we know that 0 and 1, that means we are going to fetch the value which is 20. So that 20 value will be displayed. Afterward a tab space will be given. So there is a tab space. Then afterward again it is going back. So afterward j++, so the value of j will be incremented from 1 to 2. Checking the condition, 2 less than 3, perfectly fine. So here again coming inside, again printing on the screen and taking the value from aij. Now the aij value is 0 and 2. So a02, we know that 0 and 2, that means the value is 30. So that 30 value is taken and that 30 value is displayed. Again it will go back and again j++. So here the value of j will be 3 right now. Then afterward checking the condition will be false because here j is not less than 3. Both are equal. Now understand, after completion of first for loop, means when the condition false it will come out, we are giving a statement that printing on the screen /n for the next line. So by writing this line printf /n, we will be going to the next line. Why we are doing this? The reason is that because here we are representing as the table. So here this is going to the next line. Then afterward it is a loop. So it will be going back. The inner loop is over. So it is going to the outer loop. Now here again we are having is the I++. So the value of I will be incremented. That is 1. Again checking the condition. I less than 2, 1 less than 2, that is perfectly fine. So here it will come inside. Now again the inner loop will work. The inner loop is for the column. So here again it will be start from j equal to 0. So the value of j will be 0. Then afterward j less than 3. So here 0 less than 3 condition is true. Again coming inside, again printing on the screen. So %d will take the value from aij, and we know that aij. So here the value of I is 1 and the value of j is 0. So here 1, 0. So a 1, 0. That means we are going to fetch the value which is 40. So this 40 value will be displayed on the screen. Then afterward /t. So here there will be a gap. Then afterward it will again come back because this is a loop. So afterward again j++. So the value of j will be incremented. That will be 1. Condition true. 1 less than 3. Again coming inside. So again it will be printed. And this time the value will be 1, 1. So here 1, 1. That means 50. So this 50 value we are going to take. Then afterward /t for the tab space. So tab space is there. Again it will be going back. Again j will be incremented. So the value of j will be 2. Again condition true. 2 less than 3. Again coming inside, printing on the screen, %d will take the value from aij. And we know that I is 1 and j is 2. So here 1, 2. 1, 2 means 60. So here 60 value we are taking and displaying on the screen. Then afterward it will be going back. And again the value of j will be incremented. And we know that the value of j will be 3. So here the value of j will be 3, 3 less than 3. So here the condition is false, program will come out. And the next line is printing on the screen, which is printf/n. So here the next line cursor will wait. Now afterward program will go back. So after that we are having is the next line, that is I++. So the value of I will be incremented, that is 2. Now I less than 2. So here 2 less than 2. Again condition false. So for that it will come out. So this is how we can see that here we have displayed the matrix, or we can say that a table or the 2D array. There is one more way by which we can initialize the array. So now we are learning that. So let us suppose that we are going to declare an array. So I am writing here, let's say int. So that means it is integer type. Then the name of array A. Then 2. So this is a row. And then 3. This is the column. So there the array is declared. So by saying int a 2, 3, so we are declaring an array. So this is called declaration of 2D array. So one 2D array is declared. We know that there is one way of initializing the array, that's starting from the curly bracket till the curly bracket end. This is called the initialization. So here there is one more method. We can go by index values. So we can say that A is the array. So here at 0th row, 0th column, we are providing the value which is 10. This is also the initialization. So here we have to provide all the initialization one by one. So here again A0 and 1. So row and column is 0 and 1 and the value is 20. Then at 0 and 2, there the value is 30. Now after that we are saying A, then 1. So this is the first row, and then 0th column, the value is 40. Then afterward A, 1. So this is the first row and first column, the value is 50. Then afterward A, 1, 2. So first row, second column, the value is 60. So this is how individually we can also initialize the value. So here we can see that 0, 0, 10. So that means A 0, 0 we are giving the value 10. Then 0, 1 we are giving the value 20. Then 0, 2 the value we are giving is 30. Then afterward first row means first is the index. So here 1, 0 we are giving value 40. Then 1, 1 the value is 50. And 1, 2 the value is 60. So this is also the way of initializing the 2D array. So these all steps we can follow and we can initialize the array. So these are the two ways of initializing the array at compile time, because when we are doing the coding at that time we are providing their values. But if I want the values from the user, means on the runtime if I am asking the value, that is called runtime. The program is running, we are asking the value from the user. So from there we can simply apply the for loop. Here we can see that there are two dimensions. So one we can see that here is the value is 0, 0, 0, then 1, 1, 1. So that is depending upon the rows. The rows are 2. So one loop we can provide here. We can say that for, let's say the I we are taking. I is starting from 0 and I less than 2 and afterward I plus plus. So here this is the outer loop which is for the rows we are providing. Then we can see that there is one more dimension where the values are 0, 1, 2 and again 0, 1, 2. So for that we are taking one more loop here. So we are saying, let's say 4, and we are saying j is equal to 0 and j less than, we know that here the dimension is 3. So here less than 3 we are providing, j less than 3, then j plus plus. So whenever we are having the 2-dimension array, the 2 loops are required. So this is the inner loop. Inside this loop, if I want the values from the user, we know that here we can take a simple standard that A is the name of array. So we can provide here simply saying scanf. Scanf means taking the input from the user, then %d, that is for the integer value, then add the address of which address we are taking. Here we are taking A. So here A is taken. Now inside that, we know the first dimension is belong to I. So here I we are taking. Then afterward we are taking the second dimension, that is J. So J we are taking. So I and J we are taking. Then afterward semicolon. So this is a scanf statement we are providing. Now we are closing the inner for loop. So here inner for loop is closed, which is for the column. Now the outer for loop we are going to close, which is for the rows. So by using these for loops and inside that we are using the scanf statement, so that complete code is going to take the input from the user. Now here this is the runtime initialization, because when the program is running at that time we are asking the values from the user. So this is the runtime initialization. So if in the existing program we are removing the first way of initialization, which is the compile time initialization, and we are putting this code here after the int declaration, so that program will become the runtime initialization, means we are asking the values from the user. So at that time all the values will be taken from the user and runtime values will be initialized. We can see that this scanf line, simply if we are replacing with the printf, so that will giving the output. We have already discussed this line. We know that 2 for loops was applied for the rows and column, and there printf statement was applied for giving the output. So this is how we can initialize the 2D array. So one way is the compile time initialization, where we are providing the value. So here the compile time initialization we are giving all the values. The second method is there, we are providing all the values. But here whenever we are taking the values from the user, so here this is the runtime initialization. So that is all about the 2D array.